longer period afterwards. For example, the piece of work that's on the front of the FEAT information leaflet there, a piece of ours called Magnetic Movie, we made in 2005 after being at a space sciences laboratory, and the whole time we were there for 6 months every day, and the whole time we were there, the scientists were really confused about what we were doing there and really suspicious, but we managed to interview some of them and they'd go along with it. And then it wasn't until about 5 years later that we actually went back to the lab, and their attitude to us had changed so completely because the work had been out there, it had been exhibited in spaces that they kind of had a high regard for, and they'd had people coming back to them who had seen the work, so they understood that the work could be far-reaching. And even though, like one of the scientists we worked with on that, he is describing magnetic fields, and when we showed it to him, he said, it's almost accurate. And we were like, he hasn't got the point. But then he had scientists contacting him that he works with in other labs, NASA labs in the US, saying, we didn't know you'd done these experiments. And so that, it's throwing up kind of questions around what they're doing.
But the magnetic fields in this movie are based on some models, or they are artistic recreations? Or?
They're artistic recreations to the extent that scientists, they actually represent planetary magnetic fields and interplanetary and solar magnetic fields and magnetic fields on Mars. And they've collected actual data from these places. So, for example, they have a satellite going around Mars and it will be capturing magnetometer data, and then they can plot that actual data. But they use all these masses of lines to represent the magnetic fields, where, of course, already they are kind of creating their own mythology about what a magnetic field is, because a magnetic field is everywhere all at once. It's not just a line in space. So people start thinking, it's a magnetic field. So we're playing with that kind of language. And I don't know, I think, to get back to the question, I think it can take quite a while for what the scientists get out of it to emerge. And they're quite used to having a very clear idea from the beginning about what their objectives are. But as an artist, you're starting at that point where they're clear and you're totally unclear, and you go through your research period.
So is it fair to say that scientists want you to enter at the very end of the process, and you are interested to be throughout the process?
And I think it's important for us, it's important to go in to a project really naive, so that we're not trying to go in there knowing everything about the science, but we're learning it from the tools and processes that they're using, so that it enables us to interpret it in a different way and have a different viewpoint about what they're doing.
Yeah. Well, no, I don't want you out, but I want to give some time to Kerstin Ergenzinger and Simon Stellmer. Please give them an applause. It's another interesting conversation again. Time-wise, we're a bit over time, so I'm going to skip the little Q&A, are we doing this right, and move that to the discussion after the break. So I would like to ask Kerstin Ergenzinger and Simon Stellmer to the front. Again, a conversation about precision. Kerstin is invited to work with the nuclock consortium that is about making new nuclear clocks. Am I right? And I think her work, which is about the precision of perception, fits very well in this. I have to say something interesting about this collaboration, because until now we have heard all resident artists speak that are funded by the FEAT project, but Kerstin is not funded by the FEAT project as such, but the nuclock project funds her, because they were really happy about how we are setting up the FEAT project, wherein she can work with the scientists there. It's also interesting for the people that don't know the FEAT project that well to understand that we don't have Pina Yoldas available today, who's also one of the resident artists who works with the DiaCat project, which is about designing synthetic diamond screens for CO2 conversion. And we don't have Kuai Shen here. Yeah, who's going to work with a consortium that is about plant robots. Kerstin and Simon, are you ready? Yeah?
Yeah.
Okay. You have 2 microphones? Yeah.
Okay.
Please give them an applause.
Yeah. Okay, I also brought an object. And so I try to, well, very generally, Lucas already said, I'm really focusing on perception and on the relationship. Yeah, I'm really interested in processes of perception, actually, and then also finding ways to maybe make our own perception perceivable in a certain way. So I haven't brought any examples of my further work, but I brought this little thing, which is a modified string drum. And what you see, and it's what you see is a drum, and it's really a functional model. It's not an aesthetic model in that sense. So I just took this kind of thing what I had from sports, and then this what you see here is a material I worked with quite a lot. It's called Nitinol Flex. It's a robotic wire which you can control. Basically, you heat it up, and it contracts like a muscle, and when it cools down, it extends again. And you can control it in various ways. I did quite a lot of installations with it. It has its kinetic quality, but also if you pulse it to control its behavior, it gets a sonic quality because it swings actually in the rhythm you control it with, in the communication frequency of the chip you control it with. And in most of my works, it has become from just an observed side phenomenon in a first installation, I worked more and more with the whole quality of that material. And my last work, I only used the acoustic or sonic aspect of it and made an installation which is called Navigating Noise. That is, it's a room, it's a one-to-one piece, it's only for one person at a moment. And you enter, I don't know, do you hear anything? Yeah? Okay. And you enter a room which you actually have to have a super quiet surrounding, so the opposite of here. And it's about the idea, if I try to find maybe ways of making perception perceivable, is to work with adoption processes of our different senses, and then about the ability that you can scale down and then maybe slowly experience something which you normally overhear, overlook, overfeel, because we are always dealing with a lot of noise, beautiful noise, and we try to kind of take out frequencies, informations, and orient ourselves in our world, and by this also constantly defining our own position in the world. And it's a shifting of this position constantly. And therefore, I'm very much interested in this exchange with Simon and also with Kerstin and their group, because they are, on the one hand, they try to make an even more precise clock. So they work in all different ways. We heard a lot about quantum physics, so they also have their background in that, and particle physics, as far as I know. And then, but they try to use the nucleus for a clock instead of the atom itself, so have an even higher frequency and therefore even higher resolution of time or standardization of time. So it's kind of also opposing my interest in. I'm kind of interested in making ambiguity precise. So it's the opposite in a certain way, and therefore it's a very challenging confrontation and a very open-minded one. And to start again with this object, we've had one really long meeting in Vienna, and then Simon visited me in the studio in Berlin. So they showed me their experiments. I tried to show them some of my experiments or my pieces. And then yesterday I visited collaborators of them in Munich, and they showed me their experiment. And we kind of agreed on a certain way to go, because for first maybe product or piece, I come from my direction, and with my interest in noise and also all the questions that popped up from my last piece, where I started to work much more deeply with the acoustic orientation and sound and perception of sound in relation to our movement and our body. And I'm just starting to dig more into the phenomenon of rhythm, where time also is a fundamental issue. So, and also they deal a lot with noise all the time. They try to get rid of what noise to generate observe maybe a super precise signal. And it's shifting what is noise and what is the signal. So I'm also interested in that idea of noise, because I think it's not only an opposition. It's something, it's always shifting what is noise and what is signal. And we, it's a condition of our perception, but it's also a figure of thought. What can it, if we try to take rhythm and noise as something that is not, it contains everything, and that can lead to different ways of thinking by finding the in-betweens and maybe also locating different kind of rhythms within perception, but also within thinking and then within conversations. So what I'm doing with these things, I play you some sounds, what they make, sonic acoustic experiments. I control, for these experiments, I didn't use any I just took little frequency fragments from the navigating noise installation just to see what acoustically happens with these string drums. But the idea is from the image of rain, or the noise of rain, which is also a statistical noise but contains so much information, and also you always, while it's evolving, it's always singular, but you know it, and you find all kinds of associations and things, and I would like to try to do a study in noise where you maybe can, there's also a turn sometimes towards a signal on information, but related to your perception, maybe also to the place where you are in that installation. So I just play you that as an example. That is not the one I wanted to play first, so you have the... That's from that one. And it's actually another one. And now it's okay. Now I'll play you the other one. I think I opened the wrong one. Hey. I wanted, I need to learn that one. So these are examples, and yeah, then maybe we're thinking about, because the really good thing is that we're not bound to this 1 year. We really want to continue in our collaboration and afterwards try to maybe find a way to really do something together where we both or all know not yet what's going to be. For my idea is that I really love to do something which in the end is perceivable, obviously, and has to do something with movement as kind of a situation, and really contains reflections on time on very different levels, and I'm really open to whatever happens. So that's basically all.
Simon, what do you think about this all so far?
Yes, so now our sort of point of view from the scientists. This is sort of the first art project that we are trying to build, and it builds onto installation that Kerstin did before. And later, as she said already, we'll be moving towards optical clocks, or clocks in general, that will perform much better than the clocks that we have now. But before we do so, we have to characterize the systems that we're looking at. And the system we're looking at is a nucleus, where we try to find a very weak, very faint state within this nucleus. And as I said, it's very faint, it's very weak, and it's surrounded by a lot of noise. So this connects to Kerstin's work, that within all of this noise that we are facing in our experiment, we have to extract very small, very faint signals that lead us towards a state that anyways we later on want to use for this clock. So in the first stage of our project, on the scientific project, but also on the art project we are doing together, we're facing a lot of noise, and from this noise we're trying to extract a small signal. So this is sort of the first project that we are doing together, where we are connecting to Kerstin's work on navigating with the noise. And the little drum that we looked at right now is going to be one drum out of many, many. So I guess the first piece of art that we are sort of trying to sort of build will be a cloud of those kind of drums, all of them producing noise. And when navigating within this field or this cloud of drums, we can make the drums, or the sort of the computer that controls it can, depending on the position where we are within space, make the drums sort of resonate or emit a signal that's meaningful. So by navigating through these sort of field with those drums, we can produce a signal that's meaningful. And that's the same as we are doing experiments. So also in our experiments, out of a floor, out of noise, we're trying to extract very small, very faint signals. So this is sort of the first sort of analogy between the work that we are doing together and the work that's been going on in our labs. And now I will talk about a little bit about the science that we are doing. We already heard like 2 presentations before that